Okay, today we're going to finish up polynomials part 2. We're going to graph them in our calculator, classify some, and work through some word problems. First of all, let's start with word problems. First example, the cost of manufacturing a certain product can be approximated by this function, where x is the number of units of the product in hundreds. So the cost of manufacturing a product is this function. You plug in an x, it's going to give you how much it costs to manufacture the product. Evaluate f of 0 and f of 200. Granted, remember, where x is the number of units of the product in hundreds. So that's 0, and that's 200 hundreds, or 200,000. And describe what the values represent. So all we're going to do is plug in those values from the function and describe our answers. First of all, f of 0. Okay, go through the math, you get 45. f of 200, plug in 200 in for x, and you get 23,996,445. Let's describe it. F of 0, that's the initial cost before manufacturing any products. So that's the cost of manufacturing no products. So that would be your raw materials, the people working the manufacturing lines, etc. But that would be your cost without producing anything. Then f of 200, it's the cost of manufacturing 200,000 units of products. Let's try another one. The example is a little wordy, but let's work through it. Cardiac output is the amount of blood pumped through the heart. The output is measured by a technique called dye dilution. For a patient, the dye dilution can be modeled by this really long and detailed function, where t is the time in seconds after injection, and f of t is the concentration of dye in milligrams per liter. So t is your time in seconds after your injection, and f of t is the concentration of dye in milligrams per liter. So, and I did say, phew, evaluate for t equals 4, that's time in seconds, 4 seconds, and t equals 17 seconds, and describe what the values of the function represent. I didn't show the work here because the equation was really long, but I plugged in 4 for x, and then I plugged in 17 for x, and I see a typo here. I apologize. Okay, you can verify that on your own, but I plug in 4 for x and 17 for x, and those are the values I get. And what does that mean? F of 4 is the concentration of the dye after 4 seconds, and it's in milligrams per liter. Milligrams per liter. The concentration of the dye after 17 seconds. Alright, so those are our 2 word problem examples. Next we're going to describe polynomials and identify the number of real zeros using your calculator. So get your calculator out. We're going to be using the y equals function in the calculator and typing in the function. Example, graph each polynomial function on a calculator, describe the graph, and identify the number of real zeros. We first type this one in for y1 in our calculator and hit graph. And this green graph is what shows up. Now it says describe the graph. And it really is that simple. You're describing when you see it, what you see. Up, down, up. From left to right, the graph increases, decreases slightly, increases, decreases slightly, then increases again. It crosses the x-axis 3 times, therefore appears to have 3 real zeros. 1, 2, 3. Next example. Plug this into your calculator in y1 and hit graph, and that's about what shows up. From left to right, the graph decreases, then increases. It doesn't cross the x-axis, therefore has no real zeros. This one would give you an imaginary answer, a complex number. Okay, 2 more. Plug that in for y1 and hit graph, and again, we get this funny looking graph right here, which is actually cubic. From left to right, the graph increases, decreases slightly, then increases again. It crosses the x-axis 3 times, so there appear to be 3 real zeros. 1, 2, 3. Last example. X to the 4th, x squared minus 2. Graph it and push graph in your calculator. From left to right, the graph alternately decreases and increases. So increases, decreases, increases, decreases. Change in direction 3 times and crossing the x-axis 4 times, having 4 real zeros. Okay, something this complicated, your description is going to be as accurate as you make it, and I'm asking you to keep it accurate. But then the real zeros is how many times the graph crosses the x-axis. That's all we have for today.